This is kind of what we saw with fires in the past couple of years that reach a certain size and then just start to create their own weather. So let's talk about how all of this happens. It doesn't happen with just every wildfire that pops up. It has to be a certain size. Once it reaches a certain threshold, then you get a large pocket of air that is heated by that fire, and that air rises up. It's the same thing that happens with the chimney over a fireplace. Warm air rises, but as it rises, there's still some moisture in that air, even though it has been heated by the fire. And the moisture, as it rises in to the upper levels of the atmosphere, where it's a little bit cooler, that moisture condenses and it forms those pyrocumulus clouds. Now, that's not the end of the story. This actually has an effect to intensify the fire, because where that air has risen up, well, now that creates something of a vacuum. So air has to be drawn in from the sides, which continues to feed the fire. You're just feeding new oxygen into the fire, so it's hard to get it to be contained by the fire crews, and this helps it to really race upslope in a lot of locations. Then you add the possibility of it becoming a pyrocumulonimbus cloud, where it tries to produce its own rain, but it produces its own lightning. And if that lightning strikes outside of where the fire is already ongoing, it can start new fires outside of the existing fire. And if it tries to drop some rain, well, that rain doesn't have much of a chance to reach the surface. It's going to evaporate before it gets down to the fire. But the rain-cooled air that flows out from farther up in that pyrocumulonimbus cloud can spread out and help to take the existing fire and push it even farther away. So this is a complex setup, but it's kind of a self-sustaining feedback loop that these large wildfires can just feed themselves. And that's what the fire crews are going to have to battle, especially at the North Bay, where you're able to see those pyrocumulonimbus clouds. It's much more complex than just a big plume of smoke. Saturday, we're going to see our first triple digits on the map, but I think we're going to stay just short of record territory for the first day of the holiday weekend. But then on Sunday, we're going to be close to record territory in San Jose, Santa Rosa, Livermore, and in Concord. And that's something that's becoming more common. Basically, since the 1970s, the rate at which we're setting new record high temperatures is vastly outpacing the rate at which we set record low temperatures, and fall is actually one of the months that is warming up the most. And we just round that off to September, October, November. That's meteorological fall, warming up by 3 degrees just over the last 50 years. And that's statistically significant. We just had a Labor Day heat wave 3 years ago, and we're in for another one this weekend. Yeah, the fog and smoke and haze all kind of jumbled together. Yeah. And unfortunately, we're in a weather pattern where it's kind of trapped in place. And part of the reason for that, and this seems like a Captain Obvious statement, the fires are still burning right now. The containment levels are going up. The fire crew is doing a great job, a heroic job of getting those fires contained, but contained doesn't mean extinguished. So as long as those fires are still burning, they're going to be releasing more smoke into the atmosphere. Now, the onshore breeze that kicks in every day helps to rearrange that smoke just a little bit. It does kind of push it from side to side, but that's a local effect. It doesn't completely get rid of the smoke, partly because of the double-edged sword that the onshore breeze is. It delivers the marine layer, which is just that cool air that flows in off the Pacific. Now, cool air is denser than warm air, so it stays right near ground level, and if you go up in the atmosphere, usually temperatures get cooler as you get farther off of ground level. But because of that marine layer, the temperatures actually go up in our atmosphere overhead, and that acts like a lid to keep everything trapped in the lowest levels. And usually that's just fog and the cool air. But with this weather pattern and with the wildfire still burning, it's smoke. Now, it has changed a little bit day to day. Remember, last week the air quality did improve for much of the Bay Area because we had a little area of low pressure offshore, and that means just less atmosphere pressing down on top of us. So that warm air wasn't quite as strong, and the marine layer was able to expand up. So we had the same amount of smoke, but it was vertically mixed in the atmosphere. There wasn't as much getting into our lungs. The pattern this week has been for high pressure to be taking over. So that presses down on us and just concentrates that smoke in the lowest levels of the atmosphere. And as the heat dome builds as we head into the weekend, it's going to have the same effect, but it's just going to be exaggerated even more. So all of this adds up to the smoke being trapped in place by just that lid of warmer air on top of us. And it does fluctuate in strength, but we really need is something bigger, stronger than just the onshore breeze. A cold front to come in and just push all this out of the way. But we're in early September. We're not even close to the rainy season yet. It's not a very progressive weather pattern, so the weather patterns tend to get stuck, which means we are stuck with another spare the air day tomorrow and again on Thursday.
Our Chief Meteorologist Paul Hagan is here to break down where this is coming from. We talked about it a little while ago why it looks so strange outside, Paul.
Yeah, we'll get to the coloring in just a moment. Let's start with where it's coming from. Those fires in Northern California blowing the smoke towards us, but it's not just Northern California. Let's zoom out for the wider perspective. This is a satellite image of the smoke visible from space before the sun started going down. And those fires, the August complex and the North complex, which includes the Bear Fire, have been blowing that smoke towards us. But it doesn't matter which direction the wind comes from, because if it blew from the east, the smoke from the Creek Fire would blow towards us. If it blew in from the south, the smoke from Southern California would be blowing in. You're seeing that mixed with the marine layer in the other box right now. But even a breeze off the Pacific Ocean, which you think would help us out, well, the smoke in Oregon is actually blowing offshore, and then it just loops around and comes towards us. So we're going to be dealing with this for a while in terms of poor air quality and just that funky look in the atmosphere. And that comes from those smoke particles and the way that those smoke particles filter out the sunlight. Usually the light that we see contains every stripe of the rainbow. You only see those stripes when it's filtered through raindrops, but the smoke doesn't produce exactly the same effect. It's the shorter wavelengths. It's the blue and purple end of the visible spectrum that's more likely to get bounced around. The technical term is scattering, and what makes it through is the longer wavelength light, and that's on the red and orange end of the spectrum. So it's the same thing when you're looking at a sunset. When you're looking towards the horizon, you're looking through more atmosphere. Well, now we're just looking through more of those smoke particles, and all we see is that yellow and orange that's left over, and it's even more of an effect at sunrise and sunset until right now, when it's so thick that it just blocks the light entirely, and earlier than normal sunset, even though technically the sun is still above the horizon. Of course, air quality has been an issue once again, but the air quality map maybe not quite as bad as what you would expect with that orange sky overhead. We'll talk about the role the marine layer plays in that in just a few minutes. Local fires that we had over the last several weeks that are mostly contained now produced that low-level smoke that got trapped. Now it's farther up in the atmosphere, so the marine layer comes into play. Usually, when we look at the atmosphere, the lowest levels are the warmest. It gets colder as you go up. But along the west coast, including the Bay Area, the marine layer comes into play, and that changes things a bit. Usually, warm air rises up. As long as the surrounding air is cooler, it'll keep going up, and that disperses any smoke that's near ground level. The whole atmosphere has a way of stirring itself vertically. That changes once the marine layer makes its way in, because we get what's called an inversion. The temperature actually goes up as you go up, and that traps things on either side of the boundary. So if we have low-level smoke, that gets trapped, but that has been diminishing as the fires locally have been more contained. It also keeps the upper-level smoke trapped in the upper levels of the atmosphere. So while we're seeing the sun being filtered out by that and producing that orange glow, it's not settling all the way down towards ground level to severely reduce our air quality. Now, it's still an issue. It's going to be an issue for the next several days. A lot of it is fog, but now it's fog and smoke that are jumbled together. We talked about that at the top of the hour, how the lack of a sea breeze just allowed that smoke that was in the upper levels of the atmosphere yesterday. So air quality for us was okay. That all settled down to ground level, and now it's trapped. So the air quality is going to be slow to improve. But let's talk about why the sea breeze just shut off basically today. And it has to do with the smoke. It's all part of a feedback loop. Let's look at what usually happens. Once the sun comes up, it goes to work trying to heat up the ocean and tries to heat up the land as well. But the land heats up much faster. Water has a higher specific heat capacity. It just takes longer to warm up. That's why the Pacific is always cold. So the air over land heats up much faster and it starts to rise. Warm air goes up. That's why if you have an attic, it's always warmer. As those air parcels rise up, they leave a relative vacuum underneath. That's an area of low pressure. Now over the water, it's the opposite scenario. That cooler air over the water is more dense and it sinks down. The air kind of piles up, creates an area of high pressure. Nature always tries to even out any differences, so the air is going to flow from high pressure to low pressure, and that's all that wind is air moving around in the atmosphere, and that's the sea breeze that usually kicks in every day and helps to reinforce the marine layer and help to keep us from having the worst air quality yesterday. But what was different today and yesterday is that we had that smoke overhead. It blocked the sunlight yesterday. Temperatures didn't warm up very much at all over the land, so gradually this whole mechanism shut down and the air quality just got worse and worse without that sea breeze to help kind of circulate the atmosphere overall. This is the current air quality, and it's just awful, very unhealthy for much of the Bay Area. Let's talk about how things are going to change over the next several days. We'll back up to what was happening yesterday. We had light winds in the upper levels of the atmosphere from the north, bringing more of that wildfire smoke into the upper levels of the atmosphere, coming down from Northern California, coming down from Oregon, even Washington State. And the smoke that had settled down into the marine layer was just trapped here. That has not changed. What has changed today is we have very weak upper level winds, so that new ash and smoke is not being sent into the atmosphere overhead. What's up there, though, is still settling down into the marine layer, and that's why our air quality has gotten even worse today. Let's get to the better news. What's going to happen over the weekend, the upper level winds are going to pick up again, but out of a different direction, out of the southwest, and that's the least smoky direction, so that smoke in the upper levels of the atmosphere is dispersed. And the sunshine, it's not going to be blocked by the smoke anymore. It's going to help to warm up inland portions of the Bay Area. Why is that good news? Warm and smoky sounds even worse, but it's going to help to get the sea breeze to kick back in. The temperature difference we need between the coastal spots and inland portions of the Bay Area, it's that temperature difference that drives the sea breeze circulation. It's not going to get rid of the smoke. It's still trapped in the marine layer. It's going to stir it around just a little bit. It'll help somewhat. The really good news, there's going to be a storm system that approaches the coast by about the middle of next week, Wednesday or Thursday. That means deep and strong onshore winds to act like just a bulldozer or a squeegee to get the smoke out of here, a lot of it. But also good news is that area of low pressure allows the marine layer to get even deeper. That draws it up and promotes vertical circulation to mix everything around. So the air quality will be heading in a much better direction. Should be a dramatic improvement by the end of next week. But we got to get through the weekend first.